Hello, I'm Justin. I'm an applications engineer for Transtherm, and today we're at a data center site for a university in the Midlands to look at this project that we've been working on. So this is our adiabatic V-cooler. It's been designed as two half-V units to operate as an N+1 configuration to give increased redundancy and resilience for this data center site. So when we started looking at this project, we were originally looking to make a carbon copy of the original system, a free cooling unit serving a compressor-based chiller, which would then serve the data hall. But through working with the consultants and contractors on this site, we've actually moved towards a compressorless solution due to the adiabatics allowing the system to achieve the lower water temperatures, which allows the system to run without requiring the originally designed chiller. This helps save on both space on site, because obviously you don't need this unit in addition to the chiller. This also saved on the initial capex, and it will continue to work as a saving for site due to the ongoing operating expenses and efficiencies of these units. Over here we've got this valve arrangement that we supplied for this site. We've got a 3/4 valve here and an actuated isolation valve. The point of these two valves is within our control system we'll be able to divert the flow if the water is being overcooled. This will help stop any water returning to the data center too cold and resulting in the risk of condensation buildup elsewhere in the pipework and causing damage in the electrics. Regarding the actuated isolation valve, that one is controlled by some fault logic. So if any of the fault conditions are experienced for the unit, then the unit will be isolated to prevent any risk of actually injecting heat back into the system. This will be a particularly important consideration for the summer months if there's an issue with the adiabatic system and it needs to be maintained for whatever reason. And then the full load would then be diverted to the other unit whilst this one is being maintained and repaired, and giving the data center that extra resilience that they need to operate with. Right, so from here we've got the pump sets on site installed within this GRP enclosure which we've supplied. Each pump has its own individual control panel with its own logic and its own power supply, so if any fault occurs on any pump, the other pump can ramp up to full duty and pick up the slack. This gives the system the N+1 redundancy, so that if anything goes wrong, the data center doesn't lose any performance and can continue operating at full capability whilst the components are being repaired. Thank you for listening to me talk about this project that I've been working on, and I hope you found it interesting. Thank you. Bye.